So you've thought about adding some layer 3 redundancy to your network. Or you are studying for your CCNA, or you just want to become more knowledgeable on the subject. Either way, it's never a bad idea to have some redundancy in key parts of the network. Today I'm going to show you how to configure Cisco's hot standby router protocol. I'm going to go a little bit more in depth and also show you how to track specific links to fail over the whole standby group. And I'm also going to show you the magic behind it and how it actually works. Okay, so maybe you are used to having a topology like this, where you have a single router connected to the internet and a layer 2 switch, and you have your hosts and your wireless access points coming off of this guy. So in this video, in showing you how to configure HSRP, we're going to have something like this, where we have redundant firewall-enabled routers. And I also threw in dual internet providers as well. So you could have a dual single home connection where you just have one provider and it breaks off to both of these routers here, and they might be running something like HSRP on their side as well. But for this example, we're going to have provider 1 and provider 2. Which is going to be reachable at this 8.8.8.8 IP address. And so let's get started. First, let me get rid of this right here. Okay. And then let's get started with the first step. So everything is configured to work except for the configuration necessary for HSRP. So let's start by going into router firewall 1. Now I haven't even assigned any IP addresses to these to the LAN side yet either. So I thought that I would wait to do that for this video so that way it can be more complete. So I'm going to put these, I'm going to give these a RFC 1918 address in the, with a Class C subnet. So we're going to go 192.168.10.0 network /24. So the first thing you're going to want to do is go into interface configuration mode. So we see we have a fast Ethernet 0/1 connected to router firewall 1 on our LAN side. This is where HSRP is going to be running. So there's going to be a virtual, actually let me go up here, and the virtual IP is going to be 192.168.10.1. So I should probably put that up there first. So depending on which one is active, whichever one is the active virtual gateway is going to accept requests for the destined for the virtual MAC for 192.168.10.1. So they're both of these are going to have IP addresses assigned to their interface, but they're going to share that. These two are going to share this virtual IP, depending on which one is active and which one is in standby. So let's go into interface configuration mode. So we'll go fast Ethernet 0/1. And we'll go ahead and give this an IP address of 192.168.10.2. And a /24 subnet mask. So 255.255.255.0. Okay. And then let me go ahead and configure router firewall 2 with an IP address as well before I actually get into the HSRP part. So we'll go interface fast Ethernet 0/1, IP address 192.168.10.3. Now, why did I put this at 10.2 and this other one at 10.3? Because, like I said, the virtual IP will be 192.168.10.1. So we want to bump them up. Okay. So now we should have, let's open our PC, which is actually a router in disguise as a PC. Let's try to ping, make sure we have reachability. I'm always leery of certain things in GNS3 where I have issues once in a while where I won't have reachability, and it has nothing to do with anything that's been configured wrong. It's just sometimes it doesn't work until you shut down or do a shutdown and a no shutdown on an interface or an SVI. So let me just make sure I can reach 192.168.10.2. So send our ARP and then 100%. 10.3. Okay, perfect. So here's where the magic comes in, because we have these two routers, and the PC, and clearly in a real life network, you're going to have many PCs and other devices coming off the switch, and you may even have different zones coming off of your routers as well. Maybe a DMZ or something. But we know that we can only, this PC, if we do a show IP route, we see our default gateway is 192.168.10.1, which is going to be this virtual IP up here. So we can only point this PC to one gateway, and that's where the magic of HSRP comes in, or any first hop redundancy protocol for that matter. So VRRP or GLBP. So let's go and configure this, and we'll start with router firewall 1. So we're still on fast Ethernet 0/1, and now this is super easy. This is probably one of the easiest things. You go standby, the standby group number, so we'll go with 1. Actually, we'll go with 10, just because the third octet is 10. The switch is on VLAN 10. So we'll make it 10. Standby 10 IP, and then 192.168.10.1, which is our virtual IP. Now, we're going to do this same exact thing over on router firewall 2. But then we have a situation where they're going to negotiate who is active and who is primary, because I believe the default priority is 100. So, and we see right here, HSRP, change state, fast Ethernet 0/1, state standby to active. And that's because it's not receiving any sort of communication. There are no hello messages coming from router firewall 2, so it's the only one in its group right now, so it went into standby. So what just happened there is it just sent a gratuitous ARP to this switch, and so that gratuitous ARP was broadcasted. So the MAC address table of the switch should be updated now for this virtual MAC, as well as the ARP cache on the you know what, actually I'm not sure. It may only be if that entry exists, but of course the PC is going to ARP for that when we perform some sort of communication. So let's just go show ARP. Okay, so no, so it's not in the PC yet, but once we initiate some sort of communication that relies on this gateway to get to another network, such as the internet, you'll see that in there. But I'm getting a little ahead of myself. I'm starting to get into how it works before I've actually showed you how to fully configure it. So, okay, so this became active because it's the only one in the group. So, and like I was saying before, once we configure router firewall 2, they're going to auto-negotiate who is the primary and who is the secondary. So who's active, who's standby. We don't really want that. Normally you want to dictate what is which one is going to be the primary and which one is going to be secondary. And that might be, there might be several factors that play a role in that. One might be the fact that maybe this is a more powerful router. Maybe this one is kind of like a more dinky router. Maybe this is a 2921 and this is an 1841 or something. Or maybe based on the providers. Maybe this is your primary provider, and then this is your maybe this is a slower and maybe even more expensive provider. So we definitely want to select or tell these routers, hey, you're going to be primary, you're going to be secondary or in standby. So let's head over to router firewall 2. And I know I'm kind of bouncing back and forth, but I'm just trying to keep this configuration even. So we configure one thing on one, we configure something on the other one, and then I'm going to go back and configure the priorities and preemption, etc. So same thing on here. So the standby group has to be in the same group. So we did standby 10, group 10, and then IP 192.168.10.1. Okay. So now router firewall 2 is going to send some hellos and determine what's going on and what its state should be. And I'm guessing since router firewall 1 is already active and preemption isn't enabled, the priorities are the same. Yep, exactly. He's right there. He's going to negotiate himself as standby. Okay, so actually, now that right there is a very basic HSRP configuration. If you wanted to, you could be done. This PC is pointed to 192.168.10.1 as its default gateway. This is just layer 2 here, and traffic is going to be forwarded through Fast Ethernet 1/1 out Fast Ethernet 1/14. This will accept it since it's active and forward it out to the provider. But of course, we don't want to do the bare minimum here. We want to go a little bit further and define those other parameters, like I mentioned, such as, hey, who's going to be active, and are you going to take over again if your priority drops, and that kind of stuff. So let's go back over to router firewall 1. And we want to ensure that router firewall 1, we want to make sure he is going to be primary. So we're going to raise his priority up just a little bit. So we'll go standby 10, priority. We'll just do 105. Why not? 5 more than what the default is. But that 5 more, it doesn't matter. It could be 101. But as long as it's higher than the priority of the other router in the group, he's going to win the election for being the active virtual forwarder. So now we've configured the priority. Now we're not going to do anything with the priority over here, 'cause like I said, it's already 100. So we want router firewall 1 to be primary, so we're good there. But what we do want to, what we also want to do is we want to enable preemption as well. And preemption is going to allow him to take back over as the primary if there is a change in priority. So say router firewall 2 was active for some reason without the preemption command. If he came back online, even though his priority would be higher, he would stay in standby. Now, there's a reason why this isn't enabled by default, and that is that the reason for that is because sometimes convergence time, especially if you have multiple convergence events for multiple protocols going on, like spanning tree, and then you've got your convergence with HSRP, which doesn't take long at all, but sometimes there can be, there's a few packets that might be dropped, and that could affect the flow of traffic in a very busy network, just the smallest amount of downtime when things are switching over. So maybe you would want to make it to where, yeah, router firewall 2 is going to take over if this goes down, or if provider number 1 goes down, which I'm going to show you how to configure that coming up here in a few. But maybe you don't want router number 1 to take back over. because hey, one failure is enough. We'll just wait till it's after hours, and then we'll get router firewall 1 switch back over, so we don't have any further interruption. You don't want that flapping back and forth. But normally I configure both with the preemption command, because I don't mind having that switch over, especially if I have a reason why I really want this guy to be the primary router. So of course, in a failover to this lesser router, if you will, or this more expensive provider, of course I'm going to want router firewall 1 to come back to be active again once they're once it recovers from whatever the fault was. So anyways. So that's pretty much it over here. So we go standby 10 and then the virtual IP. We set a priority of 105 and the preemption command. So over here, we're just simply going to enable preemption for router firewall 2 as well. Okay. So now let's just do a quick test and see if we have reachability to our internet, our 8.8.8.8 from our PC. Just going to send that ARP, and success rate is 100%. So we have reachability, and actually let's just do show ARP. And there you go. So now we have 192.168.10.1, the hardware address, and what you really want to look at is every time I see this over here, this 07AC, that right there is going to tell you it's an HSRP MAC address. So we just forwarded the traffic through the switch, and the switch is aware of which switch port to send to forward that frame out of, because of the MAC address table, which is saying that, hey, this MAC address right here lives off of Fast Ethernet 1/14. Sent it to router firewall 1, which accepted the frame because it is active and will accept traffic with this MAC address. Stripped off that frame, looked in its routing table to see where to go to get to 8.8.8.8, made that forwarding decision, re-encapsulated it with stuck on another layer 2 header with the MAC address for its egress interface and the as the source, and the destination MAC address for whatever the MAC is for Fast Ethernet 00 here, and on its way it went. So there you have it. So that is HSRP. So if you were just watching this video to learn how to configure HSRP, then that is pretty much it right there. Now, you might want to stick around for a few more, because I'm going to show you how to configure it where, say, this guy goes down, or say provider 1 goes down altogether. What then? Then we have a black hole. So we want to say, because I mean, already by default, if this link right here fails, or this router fails altogether, he's going to take over as he's going to take over as active, because he's not going to. There's going to be no layer 2 adjacency, because this is going to be gone. Either this link is going to be gone, or this whole router is going to be gone. He's not going to receive any replies back to his hellos, and he's going to assume that his neighbor's dead, and he needs to become active as soon as possible and gratuitously ARP that virtual MAC, out this Fast Ethernet 0/1, which I'm going to explain to you how that works at the end, and that's what I meant by explaining the magic behind HSRP. So we'll get to that. So again, so let's say that this doesn't fail, or this router doesn't fail. Let's say this WAN link fails, or the provider fails. How would we configure that in a scenario like this? So what we'll do is we'll go back over to router firewall 1. And we'll simply create a tracking object. We want to track the line protocol of Fast Ethernet 0/0. So we'll go track, and let's do track 1. Interface, Fast Ethernet 0/0, line protocol. Now, you can play around with some fancier options where if there's, you can set the delay. So you could set a figure for what would be considered down and what would be up. So this tracking object could go down if there was if your delay met the threshold, which is really cool. But we're not going to worry about that. We just want to track the status of the interface and say, hey, if this goes down, let's do something about it. So here we go. So we have track 1, which is up, of course, because it is up. So now we'll go back into Fast Ethernet 0/1, and we just go standby, and then our group, which is 10, and then track 1, and then how much do we want to decrement the priority if this fails? Well, if this fails, in this topology, this router is only good for the internet because that's the only thing connected to it. So I would just consider this router a dead end if this failed right here. So let's just decrement the priority. Let's decrement the priority 100. And there it is. So just decrement the priority 100 or as you see fit for your specific scenario. And if the line protocol on here goes down, then this is going to go into standby, and then this will take over as active. So let's try it. So this is GNS3, so I think I just need to go in there and shut the link down. No physical unplugging of cables. We'll go interface, Fast Ethernet 0/0, and shut. You see that? That's cool right there. So our tracking object went down because the line protocol on Fast Ethernet 0/0 went down. HSRP changed states. So it went from active to speak. And then it's going to go right into standby, which it did. So here we see HSRP state change. Fast Ethernet 0/1, group 10 went from speak to standby. So now because this has failed, this is now our active virtual gateway right here. Now, let's go ahead and do a test. Okay, so let's just, and then we'll do a trace as well to make sure obviously it it has to go through here because you saw me shut this down, but just to, sometimes it's never believable until you do a trace route. So we'll do trace 8.8.8.8. Yep, and here we go. We see it going through. Remember, the actual interface, the IP address assigned to the interface was 192.168.10.3. So we got our ICMP reply from there, proving that it is going through here, through firewall, router firewall 2 to provider 2. All right, and then let's see that preemption command in action. So let's do a no shut on Fast Ethernet 0/0 on router firewall 1. It should immediately cause the tracking object to come back up and will cause HSRP to go back into active. There we go. Do another trace. And you see 192.168.10.2. So we're back through router firewall 1. How cool is that? I think it's pretty neat. So last thing would be is, and some of you might be thinking this already. Excuse me for a second. Let's take a drink. Some caffeine. I got to keep my energy up. So some of you might be thinking, well, what if provider 1 fails internally? The line protocol is going to stay up between here and here, because you're probably, if it's, say it's cable, you're going to have your Cat 5e or Cat 6 connected to your cable modem. So what then? You'd like to switch over to provider 2 because again, that would be a situation where traffic would still be going to router firewall 1. It would be a dead end, and we have this provider 2 up here that's might be more expensive or might be slower, but hey, at least you have connectivity. We want to tell this router, hey, if you sense that there's no internet, then also just drop the priority and switch over to here. So we're going to configure that really quick, and we're going to do it using an IPSLA monitor. Actually, what I'm going to do is I'm going to let me create a different loopback on here for that, because typically what you'll do in the real world is you want to ping a well-known IP address on the internet, like Google DNS servers or OpenDNS or something out there that is going to be up, and of course, we all know 8.8.8.8 is actually Google's DNS servers or one of them. But what we're going to do is just create a we'll create that well-known address in a loopback. So we'll just do 1.1.1.1. This is what we're going to set our IPSLA monitor to. Send an ICMP echo request to. First, okay, we have reachability. So let's say this goes down. Let's say provider 1's having an internal failure. The line protocol doesn't go down on here, so we're not going to have a failover. So let's do IPSLA 1 ICMP echo 1.1.1.1 source interface fast Ethernet 0/0. We'll set the frequency to 5 seconds for this. Okay, and then IP SLA schedule 1 start time now. Life forever. And then we will do, see, I'm getting a little disorganized. Typically, I want to make my tracking objects match up to the number. We already did track 1. But actually, we don't have to. Why add more clutter than we need? Why have track 1 tracking the line protocol, and then also having an IPSLA monitor as well? Because hey, we could get rid of that track 1 now, not worry about the line protocol, because this is going to work for us either way. Meaning, if provider 1 is having an internal failure, this tracking object that we're going to tie to the IPSLA monitor is going to go down, as well as it's also going to go down if the link goes down. So we don't need to separately track the line. I mean, you could for quicker convergence if the link went down or if the line was pulled, but setting the frequency to 5 seconds here, I mean, you might as well just go with the IPSLA monitor as the all-in-one solution. So we're going to get rid of that tracking object. We'll go no track 1. And then we're going to reassign track 1 to the IPSLA monitor we just created. And it's up. And it's already being tracked by Fast Ethernet 0/1 because we had that in there from before. So, but again, just to refresh, just in case, we would go track or standby 10, then track 1, and decrement 100. Okay. So let's test. Leave this on top. And let's test a failure of provider 1. Whoops. I meant to I meant to do a suspend, but I stopped it. So that 1.1.1.1 loopback is not saved, so this won't come back when I power this back up. So and there you go. Fast Ethernet 0/1, standby group 10, went to standby. So now we're forwarding traffic through to provider 2. That's pretty neat stuff. Boom. You gotta love it. I think that's really cool how you can just have that switch over so quick. And a lot of times, if you set your set your timers low enough, I mean, you can have this so like seamless to the end user. They don't even know. They won't even know that a whole router switch over just happened, which is really neat. So let's start him back up, provider number 1. And in order for the IPSLA monitor to come back up, we have to create that loop back again. Okay, so now look here on router firewall 1. It's going to see, hey, look, provider 1's back up. Let's go back to active because we want to use provider 1 as our primary ISP. And we also prefer, maybe to use router firewall 1 as our primary router as well. So now we're back up. And there you go. 192.168.10.2. Now the reason, in case any of you are wondering, why we are receiving a response from, and I think it would be, actually, I don't know if this will do it. But if you were on a Windows PC, you would get that ICMP echo reply back. So say you ping the default gateway of 192.168.10.1. Just like you see here, we got 192.168.10.2, which is the actual interface IP address. If you ping that if you ping this from a Windows PC, you would get a reply back from that interface IP. And the reason for that is because it doesn't actually reply. You're not going to get a reply from the virtual IP. That is just there to have that virtual MAC. Because if you know how things work at layer 2, when we reach out to a host on the internet, like say 8.8.8.8, it sees this PC knows that 8.8.8.8 is not in its network. It looks at its IP address and its subnet mask, and it says, I need to use my default gateway. Default gateway is programmed into its configuration, and if it has the MAC address, then it's good to go. If not, it sends an ARP, and this will respond with that virtual MAC, that HSRP MAC address. It puts that in its ARP cache, and it encapsulates that and sends it along its way through the wire, where the active router will accept it, receive that packet, and forward it along its way. So this being a virtual IP, if you ping it, you'll get a reply because it's going to be the ICMP echo request is going to be received. But when it sends its reply back, it's going to be from that actual interface ID, or the interface IP address. So yes, so that leads me to my last point, and that is the magic behind HSRP. How does it work? As I've mentioned several times during this video, that gratuitous ARP. So that's definitely the magic behind it. But here's the thing. I guess I never thought about this. I guess I would have known if I did, but I never totally thought it through. I was always thinking about the PCs, the devices on the LAN, and I'm like, oh, it sends a gratuitous ARP, so now those devices now know how to get to their new gateway. Well, that's not that's not how it works at all. The virtual MAC is never going to change. So this ARP cache is going to stay. That virtual MAC will be the same for this default gateway, no matter what. The way HSRP works is it updates the MAC address tables on the switches. That's it. That's the magic behind it. So when this goes down, or like we configured this right here, if this link or provider 1 goes down and the priority's decremented, either way, whatever would cause this guy to go into active mode, that gratuitous ARP, all that does is just updates the MAC address table on the switch. So the switch now knows, oh, Fast Ethernet 1/15, not Fast Ethernet 1/14. And that's really it. It's really that simple. And to show you really quick, let's go back into the switch and do another show MAC address table. Like we saw before, we're on the virtual MAC for the HSRP group is on Fast Ethernet 1/14. So let's simulate a failure. Oh, and let's bring the PC up too. Come on. It's in the way. Okay. Show ARP. So here we are. So 192.168.10.1. There's that same virtual MAC. And so let's do it. Let's simulate a failure by just shutting down Fast Ethernet 0/1. Let's see if it happened yet. Oh, there we go. Already. So there you see the same MAC address. The gratuitous ARP was sent from router firewall 2 right down to the switch. Updated its MAC address table. It now knows that this MAC address lives off of Fast Ethernet 1/15. In the PC, do a show ARP. PC doesn't care because the MAC's never going to change. That gratuitous ARP isn't for the PC, it's for the switches. And that is the magic behind HSRP and how it works. Anyways, everybody, like I said, I apologize that this video was a little bit longer than I originally anticipated. But I really hoped you learned something, and I hope you enjoyed it anyways. Feel free to reach out if you have any questions. You can contact me at rob@rmtechcentral.com. You can leave a comment in the comment section. Like the video if you want to like it. Subscribe if you want to subscribe. And I'll see you in the next video. Thanks for watching.